All right.
Always feeling good about it.
He told me the other day that it was engraved in the city that incorrect.
It's engraved in my book.
I hope so.
Yeah,
It definitely is mine by now, but I've done it so
like I
much.
could draw it. Like sometimes if you tell me something to think of, like I might not remember. Like
Yeah.
It's more the radiance I struggle with.
Yeah.
Any of the points and stuff.
All right. Okay. Today we're going to talk about revolving around other axes. Okay. So there's still going to be either vertical or horizontal lines. I guess things could be revolved around a diagonal line, but I do not know how to do that. I think that would be a lot more complicated and nothing that we are going to be expected to do. So they'll still be vertical or horizontal, but it's not going to be the X or the Y axis. So, and this is why I said it was important for us to think about that radius as like our top number minus our bottom number sort of thing still. Because today we'll be revolving around axes that are not 0. So example 1 says find the volume of the solid generated by revolving the region of F, bounded by f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. So we are taking this region right here, and we are rotating it around that line y equals 1. Okay, so what we're going to do is we're still going to think about the radius of that region. So we are still thinking about taking, in this case, since this is a horizontal line that we're rotating around, we're going to be in terms of x. We'll have a vertical line right here. And we're taking that and rotating it around the axis. So this right here would be my capital R of x. And I am using capital R of x because we haven't gotten there yet, but we're going to learn how to do problems that have like holes in the middle of them. We've not done anything like that yet, and we're going to need a lowercase r of x later, so that's why I keep using that capital R. So my capital R of x, I need to write an equation for that radius. So a lot like we did with our S values whenever we were doing the cross sections. We want to take that radius and we want to think about which function we hit at the top of that line. And so that is 2 minus x squared minus whatever we hit at the bottom. And what we hit at the bottom this time? 1. Okay, so everything we did yesterday, that second part was 0. Because it went all the way down to the x-axis, which was 0, or it went all the way over to the y-axis, which was also 0. But today, we're going to see these be in different numbers. Now, that second function that we're dealing with is generally going to be a horizontal or vertical line, so it's just going to be a number that we have there, but we've got to include it or you'll be way off on your answers. It'll help us if we simplify this a little bit, because this is not a calculator active question. So we got 2 minus x squared minus 1. I don't know why I rewrote that, because that's just going to be 1 minus x squared. That is our radius. So we are going to plug that into the equation of a circle. So we're going to have pi 1 minus x squared squared. We'll put a dx. We will write our integral. What should my limits be for this? -1 to 1, because those are my left and right intersection points for the graph, for the region. Everybody okay here? Okay, so we would need to expand this before we integrate. So I'm going to pull the pi on the outside because it's a coefficient. and this is going to be 1 minus 2x squared plus x to the 4th dx. And then I'm going to integrate, and I will get x minus 2/3 x to the 3rd plus 1/5 x to the 5th, and I'm evaluating that from -1 to 1. Okay, now you're just plugging in to evaluate, so the pi stays way out front. You're going to have 1 minus 2/3 times 1 cubed plus 1/5 times 1 to the 5th minus -1 minus 2/3 times -1 to the 3rd plus 1/5 times -1. And if it is a FRQ question, you can stop here because you have plugged in to evaluate everything. It might not be, so let's go ahead and simplify from here. You'll have 1 minus 2/3 plus 1/5 in that first set of parentheses. And then you'll have -1. You're going to get a plus 2/3 here because you're going to need to raise that -1 to the 3rd power at first, which still gives you -1. Then you multiply it by that -2/3, so that becomes positive, and the 1/5 will be negative. However, this negative right here gets distributed to those values, and it switches them all back to positive. So I'm just going to do that on this line, or well, it switches all their signs back, I should say. So I could put my 1 and 1 together, will give me 2. I'm going to have a -2/3 and a -2/3 will give me -4/3. And I got a 1/5 and a 1/5, which will give me 2/5. We're going to need common denominators so that we can put that stuff together. I'll have 30/15 minus 20/15 plus 6/15, which is going to give me 16/15. So they'll probably write that as 16 pi over 15. There. Okay, questions? All right, let's try another one. Let's revolve around a vertical line. So in this case, they've already graphed this for us. So the purple right there is the cubic. The y equals 8 is that black line right here. Y equals -1 is the red line. And then x equals 1 is the blue line. And we will be looking at this section here. No, it was not. Sorry about that. Carried away. And so this is going to get rotated around the line y equals 1. I mean, x equals 1. So your radius right here is going to be a horizontal slice because you're rotating around a vertical line. This gets spun around this line. This is going to be your capital R of y in this case, it's got to be, everything has to be in terms of y, which does give you a little bit of trouble because that purple graph right there, do we have that solved for our x? We do not. So we need to solve that for x so that we can use it over here. So I've got y equals x minus 3 cubed. What do I need to do first? Cube root. So I got cube root of y equals x minus 3. Now what should I do? Add that 3. But I don't want to put those together, so I'm just going to have like cube root of y plus 3. And so rather than calling this x minus 3 squared, I want to call it the cube root of y plus 3. So if I'm looking at that radius, the right side is hitting that cubic function, which I'm going to call the cube root of y plus 3. And then what's the left side of that line hitting? 1. So if I combine those, I've got the cube root of y plus 2. Okay, questions so far? All right, so that needs to go into area of a circle formula, so pi r squared. So pi times the radius, which is the cube root of y plus 2 squared. We're going to have a dy here. What should my limits be? Almost. Or not, I'm sorry, not 1 and 5. 1 and 5 is bad. What's he done? What has Tyler done when he said 1 and 5? He looked at the x. And what did you say, Lexi? Negative 1 to 8. Because those limits have to come from that y-axis since this is in terms of y. And I don't think that they are going to give you that one without a calculator. I think that they'll either only ask for setup if they want it on calculator inactive, or they will make it calculator active where you can do it with calculator. So let's use the calculator for it. So let me close this stuff out. We would have the integral from negative 1 to 8 of pi times the cube root of y plus 2 to the second dy. And we get 316.673. Questions? We're okay there? Alright, I think I've got one more for us to try. Okay, so we've got volume of the solid generated by revolving the region bounded by 4 minus x squared and y equals negative 5 about the line. Do I mean for that to be x equals negative 5? I don't think I do. Let's draw the first two. I'm pretty sure I meant for that to be a y equals negative 5. Or else we can't really do it. It can be done, but we can't do it yet because we wouldn't have learned how to do this. So 4 minus x squared is a quadratic that has been moved up 4 and is upside down. So like if you plug in 1, you will get 3. If you plug in 2, you will get 0. If you plug in 3, you will get negative 5. So it will look this. And then the line y equals negative 5 would be right here. And then I am almost certain that I meant for that to be a y equals negative 5, because if it is not, it is a whole different kind of problem that we're going to have a lot more trouble doing. So I think I meant to revolve around the line y equals negative 5. So let me highlight the area that we will be thinking about. Now this one is a little bit weird because you're rotating around a line that's like below that x-axis, so if you think about it a little too much, it's going to seem very strange what you're doing here. But if you just stick to the formula that I have been trying to get us to do, if we're rotating around a horizontal line, we're going to take a line that goes all the way across as our capital R of x. It's going to be in terms of x since we're rotating around a horizontal line. And that capital R of x, you just want to look at the line that you hit at the top, which is going to be the 4 minus x squared. And then I will subtract whatever I hit at the bottom of that line. What do I hit at the bottom of that line? Negative 5. So that double negative right there actually becomes like addition. And so my capital R of x is 9 minus x squared. Mm-hmm.
You just use your y, like in your equation.
At usually.
Okay.
Usually.
So when we're finding the vertical, why do we solve for the x?
So whenever you have like a vertical line, it's like x equals something, where it's a horizontal line is y equals. So it's kind of backwards from what you're, it's kind of like the x-axis and y-axis having those formulas that are opposite of that. So that same thing's playing in here. Okay. We've got our radius. We need to plug that into pi times that radius squared. That's a pi right there. And we're going to integrate that. What do my limits need to be? Okay, negative 3 to positive 3. You want the furthest left point of that region and the furthest right, which is negative 3 to 3. Let me show you a little bit of trick right here that is applicable whenever you have symmetry. If I go from negative 3 to 3, that makes it harder to plug numbers in, because I got to plug a 3 in, and I also have to plug in the negative 3, and I got to subtract 2. But this is a symmetric graph. If I only wanted to go from 0 to 3, what would I have to do? Just double it, right? This, you don't have to do this. You could do it like I have it set up here. But if you do this, it does make the work a little bit easier, because when you plug in 0, you'll just get 0 for that. So if we do this, then we'll have a 2 pi out here. We need to expand 9 minus x squared, so that's going to be 81 minus 18 x squared plus x to the fourth. And we would integrate 81x minus, let's see, 18 divided by 3 is going to be 6, x to the third plus 1/4 and 1/5 x to the fifth. And we're evaluating that from 0 to 3. And so I would get 2 pi. It still might be more than I'm willing to do without a calculator. When you plug 0 into all of that, you're going to have 81 times 0 minus 6 times 0 to the third plus 1/5 times 0 to the fifth. That's just going to give you 0 for that. I don't think they're going to do that to you without a calculator. I think that there are times where it might be helpful to use that trick. I think that we're going to do the last step of the calculator here, though, because I'm going to leave out the pi. Actually, let's go ahead and put pi in there. We're already getting a decimal. And we're getting 814.300 or 301. 814.301. Questions? Yep. Is the last, the assignment there is on that last slide. So it's 13C, 14D, 18, 21, and 24 are the ones that you're going to do here. And let me look and see if I'm going to let you use the calculator on any of those. Let's see. No calculator on 13C or 14D. Those are not that bad. 18. You can use the calculator on 18 and 24. Try to do the other three without the calculator, but 18 and 24 you can use the calculator for those.